Welcome back to my channel. I hope everyone is doing great. My name is Ravi Teja. Let's solve 15th problem of dynamic programming study plan. Longest palindromic subsequence. Given a string S, find the longest palindromic subsequence length in S. A subsequence is a sequence that can be derived from another sequence by deleting some or no elements without changing the order of remaining elements. Okay, if you see, this is the string b a b is a subsequence. Okay, and bab is also subsequence, b is a subsequence, you can say b and b is a subsequence, right? So we have to find the longest palindromic subsequence among all the possible subsequence. We have to return the longest palindromic subsequence. Okay, let's just say f of ij is a function which will tell me the longest palindromic subsequence from index I all the way up to the j. Okay, given a substring from I to j, f of ij will tell me the longest palindromic subsequence length. Okay, now if the character at I and j, if both are equal, okay, if the characters at I and j both are equal, that means I have to get the subsequence largest length, subsequent palindromic length, okay, from f of I plus 1 to j minus 1. And if I is equal to j, that means only one character will be contributing to the palindromic subsequence. If I is not equal to j, then two characters will be contributing. If you see, if I pass I to j as both 1 comma 1, then only one character will be contributing. Now if I and j are not equal, and if you see b and b are equal, two characters are contributing, so that is what I mean. Okay, so if I and j are equal, that means only one character will be contributing, and if both are not equal, then two characters will be contributing. And then I have to get the answer for the remaining subsequence from I plus 1 till all the way to j minus 1. Okay, now if the characters are not equal, then I have to get the maximum of I plus 1 till j and I to j minus 1. Okay, I can skip the current character at I, or I choose to skip the character at j. Okay, this is the answer by skipping the character at I and getting the answer from I plus 1 till j. And this is the answer for skipping the character at j and getting the answer from I till j minus 1. Okay, so if I is equal to j, that means only one character will be contributing, and if I exceeds j, then nothing will be contributing. Okay, so that is what the base cases, these are the base cases, and these two are the recurrence relation. Okay, so I just defined the same thing, I just coded using recursion the same thing. The function f taking both I and j, if I is equal to j, then one character will be contributing. Okay, so 1 to 1 is basically one character basically which is contributing as a palindromic. And if I is greater than 0, or else if the character at I and j are equal, then this is what my answer will be coming from. And if both are not equal, then my answer will come from this. Okay, if you notice, if you draw the tree diagram for this any particular recursion, okay, so my answer will basically lie from 0 to n minus 1, right? So if you draw the tree diagram from 0 to n minus 1, f of 0 to n minus 1, you will notice that there will be certain problems which will be overlapping. Okay, and whenever we have overlapping subproblems, we don't have to recompute the answers again and again. Instead of doing that, we can cache our values and reutilize it, right? So that is what I am doing here. Okay, if you see, I values are going from 0 to n minus 1 and j values are coming from n minus 1 to 0. So I just define a dp array of size n by n of type integer, and then if the answer to a particular state is already calculated, then I will be returning it, or else I will be computing the answer and then storing it in my cache. Okay, or the dp array. In the end, my answer will be coming from f of 0 to n minus 1, and then just have defined some few variables at the class level so that I can be accessing it in my function. Okay, If you analyze the time complexity for this, we are actually filling all the states of dp 2 by n by n array. So the overall time complexity will be order of n square, and space complexity also order of n square. This is basically the top down approach. Feel free to also implement the bottom up approach, and try to share in the comment section. I will be more than happy to review those bottom up approaches. And that's all about this problem. If you like the explanation, hit the like button, hit the subscribe button, and also share your valuable feedback in the comment section. I will be posting solution in multiple languages such as Java, JavaScript, and Python. If you're coming from any other languages, feel free to check it out. Thank you.